This is the Oscar BCU Tester. It tests the Favorly Gemini 2 BCUs used on the Oscar train. What does it comprise of? Diagnostic screen, TOS screen, custom designed control panel, and of course the two BCUs. The custom control panel has a master controller simulator which simulates the train line signals plus the PWM signal. Speed controller input where you can adjust various speeds to be able to control the speed switched outputs. It has the SACOV safety changeover valve for when the train reverts to auto. It's also got major brake fault for both the trailer car and motor car, and underneath we've got pressure controls for main res, brake pipe and load where you can set them to max, nominal or minimum. Okay, we've got our apply, in-shot and release valve indicators. We've also got dynamic brake cutout and dynamic brake control where we can adjust the amount of dynamic brake, and we can actually do a brake and power application for a dynamic type test. And over on this side we've got the WSP side which has all the dump valves, and you can apply skids, and you can release each bogey 1, bogey 2 for the trailer car, bogey 1, bogey 2 for the motor car. And these are your fill and exhaust valves. Okay, we've got a circuit board we designed for controlling the PWM signal and the master controller train lines. We've got an EBC5 simulator board which is used for apply, release, in-shot applications. It's got the control and brake cylinder reservoirs in there as well, simulated electronically. We've got the speed signal card which generates the speed signals for all the axles, and we've got the dynamic brake card as well as the brake pipe, master, main reservoir and load transducers. In the back we've got power supplies and of course our wiring distribution onto the back panel. We've got an isolation board there which is used to basically isolate the BCU from some of the signals, and we've got a single board computer which is running the diagnostic software. Power is fed from a 120 volt power supply, and each piece of equipment has its own circuit breakers. There's a main circuit breaker, then there's a trailer car BCU, motor car BCU, TOS CU, TOS LU, and the TOS screen. Okay, this is the master controller simulator. We can apply shunt, power, in power, max power, min brake, max brake, and emergency. And we can see the PWM signals change as well as the train line signals change. So we'll move it to shunt, and we can see that we've got the train in motor and we've got the brake PWM at 56%. Move it to min power, max power, back to off, go to min brake, max brake, and emergency. What's happening when we go to min brake is brake cylinders start applying. Get a minimum pressure applied, go to max brakes, everything starts coming on, pressure's increased, take it further to emergency, and so on. In brake, max brake, emergency, then the brake cuts out and the SACOV comes off. So when we apply emergency, SACOV valve turns off, the emergency brakes are being applied. You see up here, we've got the emergency input here is unlit. When I go back to max brakes, turns on, reverse logic. and off it goes. We have a speed switch here. We're doing 80 kilometers per hour at the moment, and the 70 kilometer speed output is lit. We can move it down to 8 kilometers per hour. That should turn off when it goes past 70 kilometers per hour. Have a look there. We're at 52, going down, decelerating. So we're almost at our 8 kilometers per hour. And take it down to the next one, which is 3 kilometers per hour. These 5 kilometer speed output should come on, and we also got a manual variable where we can run this down to 1 kilometer per hour and adjust the speed inputs till we get the outputs turning on and off as we like. Over here we've got a SACOV indicator, which is safety changeover valve. So when the BCU reverts to automatic brakes, the SACOV will become de-energized. And we've got major brake fault, trailer car, major brake fault, motor car. Underneath we've got a main res, brake pipe and load switches where we can switch between max, nominal and min. So if you turn the main res up to maximum, you'll see it changes up to maximum, and if we hold it there, we'll get an alarm. So main reservoir, pressure outer limit. So we turn it back to nominal, and go to minimum, and put it back to nominal. Similar with the brake pipe, we can turn it maximum, nominal, minimum. With the load, we've got a nominal, min, max. So at the moment, our passenger load is 0 kilograms, and we're running 3,500 millibar. Move it up to maximum. You'll see we'll go up to 8,500, 8,800. Passenger load starts increasing. Now we're at a point where it'll say the airbag will burst. Air bellows out of range. And we've got a flat airbag alarm of 65 kilometers per hour. This can be used to increase the brake cylinder pressure by having the BCU do its load compensation. So previously, where we were getting around 300 kPa in the brake cylinder pressures when we applied a max brake, we'll see what it does now. Apply max brake, and we'll be up near the 400s. What I'll do, I'll knock the load back to nominal, and it'll take some time for that load to come down. Wait for the passenger load to come down. Still at 8,000, takes a while. Okay, it's starting to come down, 6,000, 5,000. Now we should start seeing the pressure starting to reduce. Here it comes down now. So there's the load proportional input from having a high load compared to a low load. Got a dynamic switch here in the middle where we can change the testing scenario. We switch it to dynamic. At the moment we're in the brake mode. We'll switch it to power. So now we're powering, brakes released, and if we come up here we'll start to see the train start accelerating. So we'll let that accelerate up until about 80 kilometers per hour, then apply the brakes. We start applying the brakes, speed starts decelerating, and we can test our front valves. You can see they'll time out after 2 seconds, axle is locked, we switch it off, fuel valves come on, test it. You can check all trailer car and motor car boogies. Here's another cool feature we've got. We can do a brake application and we can switch on the dynamic brake. As you can see, there's hardly any pressure being built. Switch the dynamic brake back off. Pressure's being built and it starts changing the brake cylinder pressures. Switch it off. Switch back on the dynamic. Switch the dynamic brake back off. Sorry. Pressure's up. Switch the dynamic brake on. Turn it down. So at the moment we're trickling along because we've got full dynamic brake. I can wind the dynamic brake down and find the sweet spot where it starts blowing. Another interesting thing that happens here is if we do a skid on the motor car, the dynamic brake cuts out straight away. I'll skip this one here. And there you go, full friction brakes. Until we go move the controller either into power or coast, reverts back to normal. Then we can go back and do Another feature you can test is the speed at what dynamic brake cuts out at. So at the moment we're braking down from 50 kilometers per hour, 48, 47. We'll just leave this here for a little bit. Once we get below 20 kilometers per hour, you'll see dynamic brake automatically cuts out and full friction brakes take over. Okay, 20, 19, 18, 17, 16, here it comes. If we don't have dynamic brake cut out, but friction's taking over.